Hello guys, welcome to my channel. My name is Aditya Anjan Jha and my USN is 1V22CS006, and today I'll be explaining you about bubble sort in C. What is bubble sort? Simple sort. It is a simple sorting algorithm. Bubble sort is a simple and intuitive sorting algorithm that repeatedly swaps adjacent elements if they are in the wrong order until the array is sorted. Comparing adjacent elements. The algorithm loops through every value in the array, comparing it to the value next to it, making it easy to understand and implement. Time complexity. Bubble sort is an inefficient sorting algorithm with a time complexity of n square, making it suitable for small databases but inefficient for large ones. How bubble sort works. Iterative process. Bubble sort works by repeatedly swapping adjacent elements if they are in the wrong order, iterating through the array until it is completely sorted. Algorithmic steps. The algorithm loops through the array, comparing adjacent elements and swapping them if they are in the working order, continuing the process until the array is sorted. Working principle of bubble sort algorithm. Comparing adjacent elements. The algorithm starts by comparing each pair of adjacent elements in the list. Swap elements if necessary. If the adjacent elements are in the wrong order, they are swapped to their positions. Iterative sorting process. This process of comparing and swapping is repeated for every adjacent element until the list is fully sorted. Multiple passes. The algorithm continues for multiple passes, ensuring all the elements are sorted. Advantages of bubble sort. Ease of implementation. Bubble sort is relatively easy to implement, making it a good choice for educational purposes and small databases. Space complexity. It has a space complexity of 1, meaning it requires a constant amount of additional space. Educational value. Bubble sort provides a clear illustration of how sorting algorithm works, making it a valuable teaching tool. Limitations of bubble sort. Inefficiency. Bubble sort's time complexity of n square makes it inefficient for large datasets, especially when compared to more advanced sorting algorithms. Not suitable for large databases. It is not recommended for large databases due to its slow performance. Better alternatives. There are more efficient sorting algorithms available, such as quicksort and merge sort, which outperform bubble sort in terms of time complexity. Time complexity analysis. Best case. The best case time complexity of bubble sort is n, where it occurs when the array is already sorted. Worst case, n square. The worst case time complexity is n square, which arises when the array is sorted in reverse order. Average case, n square. In the average case, the time complexity is n square and happens when the elements are in random order. Time complexity. Worst case time complexity. In the worst case scenario, when the array is sorted in reverse order, bubble sort requires n-1 comparisons for the first element, n-2 for the second element, and so on, resulting in n-1 plus n-2 till 1 equals to n-1 by 2, which can be written as n square comparisons. Best case complexity, n. If the array is already sorted, bubble sort can be optimized to stop early. In such cases, a single pass through the array is enough to determine that no swaps are needed. This results in the best case complexity of n. Average case complexity n square. On average, bubble sort will require n into n-1 by 2, which can be written as n square comparisons and swaps, as the initial order of elements is random. Optimizing bubble sort. Flag implementation. Introducing a flag to optimize the bubble sort algorithm by checking if any swaps were made in the previous pass, potentially reducing the number of iterations. Early termination. Exploring the concept of early termination if the array becomes sorted before completing all iterations, improving the algorithm efficiency. Performance improvement. Discussing how these optimizations can enhance the performance of the bubble sort, making it more suitable for certain scenarios. This is the code for bubble sort, in which we create a function bubble sort, which for the first loop it starts from I to n-1, and for the second loop it starts from j to n-i-1. It increments after every loop, in which it compares the current element to the next element j to j plus 1, And if the current element is greater than the next element, then we switch the element using the temporary variable in which we store the value of the current element, and then save the value of the other element in the current element, and then swap it with the temp function, the temp variable again. After that, the loop increments for every value in the array. Now, after that, we print the array using the print array function, in which we'll start the loop from 1 till the size of the array, and we print every value of the array. This is the main function for the code, in which we take the size from the user and then create an array elements, in which we take all the input, and then we print first the unsorted array and then call the function bubble sort, and then again print the sorted array. So now we'll try to run the code. So now we'll execute this code. So we'll enter 4 elements for an array which will be in unsorted manner. So we'll get the output in sorted array as 4, 12, 31 and 56. So thank you for watching my video. See you in the next one.